Okay, so as in the last video, we have already solved the MCQs from 1 to 14. Alright, so in today's video, we will be continuing solving those MCQs from the Ecat book. So we were done with how many MCQs? We were actually done with, 14 MCQs from the Ecat book. With 14 MCQs. Okay, so in today's video we will be solving MCQs from 15 to onwards. Like, so let me scroll down it. Okay, zoom in so that it can be visible to everyone what's written here. Right, so what is 15 MCQs asking us about? Right, fund series are produced in the spectrum of hydrogen atom. We know that we have 4 types of series: Lyman series, Balmer series, Paschen series, bracket series, and fund series. When electron jumps from anywhere and goes to 1, it is Lyman series. When electron jumps from anywhere goes to 2, it is Balmer series. When electron jumps from anywhere goes to 3, is Paschen series. When electron jump from anywhere comes to the 4th orbit, it is bracket series. When electron jumps from anywhere comes to the 5th orbit, is known as fund series, which means this C option is right. When electron jumps to 5th orbit, from anywhere to the 5th orbit, is known as fund series, right? So our correct option C. Okay, let's read the 16th one. When electron collide with a heavy particle, then which of the following is produced? We have learned about X-rays production. When electron is collided with very heavy atomic number of the element, it produces what? It produces X-rays. Right? We have read about each and everything. We have discussed about K alpha series, L alpha series, right? In very detail, each and everything. What is 17 MCQ asking us about? Space around nucleus, where finding of the electron is maximum, is orbital, right? This we have already discussed. 18th MCQ. Choose the value of the red box constant among the following. They have written 2 times, right? So we have already discussed when we were driving the formula for calculating the wave number, and then wave number was the reciprocal of wavelength, right? So there we introduced a new constant, which was Redberg constant, and that's value was equal to 1.09678 into 10 to the power 7 per meter. Right? So our first option is correct. Let's read the 19th MCQ. Millikan used in atomizer. We know that, what do we call it, the entire experiment? Millikan oil drop experiment. Millikan oil drop experiment, which means he used oil drop, right? So the correct option is what? Oil. Correct option is oil. Okay. 20th MCQ. Spectrum is produced due to different wavelengths. When we were discussing about hydrogen spectrum, why there was line spectrum? Since the wavelengths which were used by the electron to jump to the higher level, there were used wavelengths, right? Which means due to their difference in the wavelength, there is a production of a spectrum, right? So our correct option is different wavelength. They are basically electromagnetic waves. That's why we are not going with the colors, because they are colorless, right? Because they are electromagnetic waves. So when electron jumps into orbit 1, then series obtained. We have already discussed 5 types of series. When electron from anywhere jumps to orbit 1 is Lyman series. So here the correct option is Lyman series. 22 MCQ. Radiation emitted by excited atom is in the form of quanta, right? This we have already discussed when we were discussing about quantum mechanical theory, right? So in the form of quanta. Quantum number tells the energy of the electron. Energy of the electron is told by principal quantum number, and principal quantum number is represented by n, right? positive particle in discharge tube is produced by ionization of gas. Okay, that we already know. When gas is ionized in the discharge tube by the cathode ray. So yes, we have already got our answer, right? So gas molecule collide with anode? No, of course. Gas molecule at high temperature? No. Cathode rays remove the electron from gas molecule? Yes, this is the right option. So our correct option is C. Correct option is C. Right? Let's read 23rd. Charge of electron was measured by millikan. Right? Because J.J. Thomson calculated the E by M ratio. Right? E by M ratio was calculated by J.J. Thomson, which was equal to 1.75 so on into 10 to the power 11, right? And I don't remember about the unit. So after calculating the E by M ratio, we were actually known about the mass. Then Millikan used the E by M ratio and the mass to calculate the charge of an electron. So charge of an electron was calculated by Millikan. Charge of the electron was calculated by whom? By Millikan. 26th MCQ, wavelength of electron was verified by Davison and Germer, because they verified that electron has the wave nature as well and wave has wavelength. Wait. Okay, so 27, the credit of discovering neutron goes to James Chadwick. Very basic, right now? Very basic. The mass of neutron is in the order. Initially, the mass of neutron is what? It is 1.6 into 10 to the power minus 27. So the order of the mass of the neutron would be 10 into raised to the power minus 27. Minus 27 kg. Okay, so 29, the ratio of ionization energy of hydrogen and beryllium is. Now here we have calculation, so we need to calculate right here. We need to calculate here. Okay, let's use something good so that it can attract us, right? Or we can actually write here. We can actually write here. Okay, so we know the formula for finding the energy, right? 13.6, wait, 13.6 into, wait. Why can't I write here? Into, okay, 13.6 into, I don't know why can't I type here, however I'm going to write, right? So 10 into 13.6 into, oh my god, actually, okay, I don't know what's happening here, however I'm trying my best. Okay, so here we are, 13.6 into z square. This is, you know what, the formula we had. Now let's find for the hydrogen first, because we need to find the ratio of it. We need to find the ratio of it, right? So for hydrogen, the atomic number is 1, right? So 13.6 into 1 square, since the hydrogen atomic number is 1 square, right? So the answer must be 13.6 only. 13.6. This is the hydrogen we have found. Now let's find for the beryllium. Let's find for the beryllium. 4Be 13.6. Beryllium atomic number is 4. So we need to take the square of the 4. Now let's take the ratio of these both, right? Because we have been asked to find the ratio of these both. So wait, now let me change the color. Pink is fine. Okay, it is not selected. Hydrogen by beryllium ratio. What we're gonna get? 13.6 upon 13.6. Now we are writing for beryllium, which is this 13.6 into 4 square into 4 square. Now let's cancel these. Let's cancel these. 13.6 cancelled with this 13.6, remaining 1 ratio 4 4s are 16. So 1 ratio 16 is the answer. 1 ratio 16 is the answer. Right? 1 ratio 16 is the answer. The maximum number of electrons in a subshell for which L is equal to 3. Here we have already discussed about each and every formula, right? Each and every formula. Let me lower down the size of it so that I can write it properly here, right? So wait, I'm gonna use this black color here. Okay, so the formula which we'll be using here is 2 into 2L plus 1 plus 1, right? 2 into 2L. L we have 3, right? So 2 3s are 6 plus 1 is 7, and 7 into 2 is 14. 7 into 2 is 14. So the correct option here is 14. 14, right? So 31 MCQ. The number of electrons in the M shell of the element with atomic number 24. Here we need to draw the electronic configuration, then we're gonna understand. So the answer is 13. You can make the electronic configuration, you can identify